isn't it? Don't we need some shortcuts?
No.
Allison, can you think of one shortcut that we learned last time we set up algebra? When we had lots of variables on one side of the scale and lots of variables on another side of the scale. What was a shortcut? I think. We gave it another name. We called it. What did we call it, Shelby? Do you remember?
I forget, but I just remember that you took away as many x's as you could until you were stuck.
As many x's what? From both sides of the equation? Both sides. Does everyone remember that? What did I call that, Jay? A legal move. Good. Jay, the future lawyer, he called it a legal move. That is what they call it. I'm thinking we might be able to find some more tricks like that to make these things go a little bit quicker, at least at this level. Well, let's figure that out. First, we're going to pass these things out again, and now that we're all involved in this routine, I'm going to take a remember by a show of hands. Someone tell me which number blocks we're going to use, the red ones or the green ones? Matt Harris? We're just going to use the red ones for now, unless we what, Shelby, like? And then if we run out, can we pretend that the green ones are red for now? Yeah. And last week, someone, and I understand this at this age especially, someone was really, really curious why we couldn't just use the same in each color, no matter what case, any old time. And the real answer is, if you are curious, is that those green ones are going to represent something very interesting but different when we get to that point. Not right now. Yeah. Thank you. We need to go in an order that will help you build on your previous experience. So, I would like everyone to, after they've finished putting their green blocks in their baggies, review with me for 1 minute. What do we call this X right here? Laura Knight, what would we call that X? In math terms?
A variable.
A variable, okay? And we talked about being able to remove like players, if you will, from either side of our balance, of our scale, when we can, in order to take a shortcut. Set this equation up and let's talk about what we find ourselves with. Set it up on your scale. I'm going to wait for you, and then I'm going to set mine up. I know it could be tempting just to look and see what the teacher has at the front of the room. So let's let you take a chance at it. All your green cubes are back in the bag, and you're just going to set this up. And Bethany, would you read that for me while you're trying to set it up?
2x plus 4x is 10.
Okay, try that one more time. I think we added something that's not quite in there.
2x plus 4x.
Is there an x after that 4? So what would it be? Is it just 2x plus 4 equals 10? Someone help Bethany out here. Bethany, choose someone to help you out for a second.
KDL.
KDL? How would you read that?
2x plus 4 equals 10.
Yeah, we just don't want to insert things that aren't there because that'll complicate the problem. And all we really have put up at this point is 2x plus 4 equals 10. So when I'm coming around, let's build that on our map. Let's build it on our map. Okay? And I would build it always with the scale part facing away from you. Everyone at the teal table's got it. Here we have the red teal table. I think we got it. And Rachel, I am just going to ask you to do something that I should have prefaced as well. Let's just use the blue pawns for now, because those white pawns, just like the green number blocks, they're going to have a very, very specific use a little bit later, and I don't want it to be confusing for us. Well, this is what I see going on. I'm looking at 2x when I walk around the room plus 4, and I've noticed that most of you are putting the 4 facing sky high, so Ms. Capola and myself can see as we walk around. Have that face the ceiling. I'm going to face mine out so that you can see what I'm doing. I have 2x plus 4 equals 10. That's what I'm saying. Does that look right to you, Matt Harris?
Yes.
Yeah, that's right. Perfectly all right. We learned the shortcut, Seamus. You were pretty good at this and wanted to go a little further. Can we do anything with our variables here that would make this go quicker? Are there any x's, Bethany, on either side of the equation that we can remove at once? No, we only have x's on this side of the equation, don't we? That's a shame. How about if we introduce one more legal move? Maybe we could remember one more legal move. After all, if we were able to remove x's from both sides of the equation, why shouldn't we be able to remove like numbers from both sides of the equation? Ben, I see an inquisitive look on your face. If I have a 4 here, and I have a 10 here, do I really have 2 4s that I could take away, one from either side of the equation? I do, don't I? So let's take this 4 away, eyes up here, from this side of the equation. And Ben, what does it do to my 10 if I take 4 away from it? It turns into a 6. So let's turn that 10 into a 6. Now rotate your red block so that there's only a 6 showing. Does this make, I'll give you a second to do that. Rachel, you have a question? Does that mean that each x equals 3? Does that agree with everyone? Does everyone think that pretty much they could do that in their head? And that each of these x's equal 3? And Rachel, I'm happy to hear you say that, because I think the first time we blurted this out, you thought we were playing chess, not algebra. And you were like, Mr. Emery, you've lost your marbles putting that thing up there on a scale we don't even use today. Rachel says that each x equals 3. Well, it's easy for her to say. She's smarter than I am. X equals 3. And well, I'm supposed to take her word for it, right?
I guess.
Okay, well, let's do something here for a second. Rachel, why don't you come on up here and prove this if you can. And the way I'd like you to prove it is the same way we're going to check all these algebra examples. We're going to replace our variables with the number that we have stated is going to be the answer. I better stand up front so I can see if this works. Oh, good. Allison Granda, does 3 plus 3 equals 6?
Yeah.
Do we have balance on both sides of our equation?
Yeah.
And our scale, even though it doesn't look so scaly? Congratulations. Did that go a little bit quicker once we decided we could take like numbers as well as like variables from either side of the equation, Seamus?
Yeah.
It did go a little quicker. Good. Let's try another one.